This is lesson 6.2, Evaluating Trig Functions with the Unit Circle. So hopefully you just filled out page 38, Unit Circle A, and the unit circle is fresh in your mind. What I want you to do now is do not look at that unit circle and try to answer all these questions. So in your mind, go to 30 degrees. Go to that first angle in quadrant 1, close your eyes. It says sine, so try to imagine the second fraction that you wrote down there. And what you should be remembering is 1/2. Okay? If this takes you a while, that's okay. I would like for you to pause this video and complete this entire page with all of the answers. So go ahead and pause the video. Seriously, pause the video so you can complete this page. Is anybody cheating and just waiting for me? No, I want you to fill out this page. Go ahead, pause the video, and I'll see you in a minute. Okay, did you seriously write down all the answers? Because if not, I'm going to know. You better go back and pause this video. Okay, let's go ahead and check. Okay, and then the ones down here. Go ahead and check all these values all the way down through x. So out of 24 values, how many did you get? And how long did it take you? So the more that you fill out the unit circle, try to close your eyes and imagine where these values are, because you have to be able to do something like this in less than 20 minutes. Okay. We're also going to be looking at some expressions here that use the unit circle to help do them. Okay, so what you're going to do is, with your unit circle knowledge, it says sine of 45 times cosine of 150. So if I know what the sine of 45 is, and I could put it right there in that parentheses, and then I'll multiply it by that fraction. So when I say sine of 45, you say radical 2 over 2. Okay, go to 150 degrees. Go there. That's in quadrant 2. Cosine of 150 is negative radical 3 over 2. And how do you multiply fractions? You multiply the two numerators together to get negative radical 6. And the denominator would be, a 4. Okay? This is not making common denominators. This is multiplying the two fractions. That 6 cannot be reduced. You can't cancel a radical number with a plain number, and so that's it. All right, let's talk about these. Cosecant for pi over 4. That would be the sine value reciprocated, so that would be 2 over radical 2. I'm going to have to clean that up. And cosine for 3 pi over 2, that's due south. Cosine is 0. So all I have is 2 over radical 2, which if you rationalize that and multiply by radical 2 over radical 2, that is going to make just a radical 2. Okay, one more. To do this problem here, we have to take 2 times the sine of pi over 6. So we have to get that value from the unit circle, plus 5, and then this value right here from the unit circle. So what is the sine for pi over 6? 1/2. Cotangent. How many people think of cotangent as cosine over sine? Cosine over sine. That's a good way of thinking of it, because I know tangent is sine over cosine, so that would be the reciprocal. Let's put this in a little box. Important fact. So let's go to 11 pi over 6, and that would be negative radical 3. This cancels here, so we have 1 minus 5 radical 3. Okay? So you might be asked to do some little problems with the unit circle values. Okay, now it is the portion of the lesson where we have to use our calculator. Okay, first of all, let's go ahead and on your calculator, find these 3 buttons right here. These ones are on the calculator. Every scientific calculator will have these 3 buttons for sure. Okay, sine, cosine, tangent. And everyone knows how to use those. Something I have to make sure I mention is you look at the mode. You push your mode button right there, and you have to see what mode you're in. Okay, so you can get this entire part of the test wrong if you're not in the right mode. Mine is currently selected on degree mode. I just have to be aware of that. If I do a radian problem, I have to switch it. Okay, and what about these three? Does anyone know where the cosecant button is on your calculator? I can tell you the most common wrong answer is, oh, it's right there, second sign, right? That is not cosecant. That is sine inverse. So that is not the problem that we want to, not the button we want to use. So to do these problems right here, what we are going to do is 1 over the sine of theta. That is the reciprocal. So you don't mess the angle. You keep the angle the same. Let's break that down. Keep the angle the same. Okay, you're just going to have to use the 1 over button. So they didn't make 3 new buttons for these because you have the 1 divide by buttons. This is 1 divided by cosine of theta, and this is 1 divided by tangent of theta. Okay, let's do a couple. Something to make note of here, if it has a degree bubble, that means it is degree mode. Okay, so we'll do these one at a time. I'm currently in degree mode, so I can go ahead and quit. I'm going to calculate cosine of 48 degrees, and it says round to 2 places, so this is approximately 0.67. This is a secant problem. Okay, a couple of tricky things about this one here. I do not see a degree bubble. That means this is radians. Radians. Look carefully. If you don't see a degree bubble, don't add 1. This is radians. So I'm going to go here to my mode, and I'm going to switch to radian mode. Okay, and I also have to know how to do secant. So this is going to be 1 over cosine of 27. Okay, keep the angle the same. Don't change 27 to anything else. That's the good angle. So 1 divided by cosine of 27, and that is approximately negative 3.42. Okay, let's do the next one. This is also radian mode. I'm currently in radian mode, so I'm good to go. Tangent of pi divided by 12, and that is approximately 0.27. And the last one right here, I do not have a cosecant button, so I'm going to have to do 1 over sine of pi over 13. Oh, we got a lot of fractions here. Okay, so we have to type 1 divided by sine of pi over 13. And this is approximately 4.18. Okay. Hopefully I didn't make any mistakes there and you guys were working with me. And here's some Now You Tries. Please try those and bring your answers tomorrow. Good luck.